move on then, or is that okay?
Yeah, it's okay.
All right. So again, so people talk about now, you know, people in this discipline, and they'll call them a data scientist. So I get really curious. I go, Google, when people query Google and Yahoo and the search engines on terms, it sometimes gives you a good clue on what's going on. In fact, early in the COVID pandemic, I got curious even before they concluded that loss of smell was a problem. I looked up this like loss of smell in Google, and it showed the trends. So in this case, I used the same idea. I said, when did these terms take off, or when did people get interested in the fields where they were actually querying Google? So Google only went back for me on this analysis to 2004. So for some reason, the term was more popular back in 2004, and then it slowed down and it started to pick up again. But the machine learning, the term itself, really took off, and you can see like in the last, 7 years, it's come strong. And then you can also see the growth, or people are looking up the term data science since it was coined. So, there are many people around the world that are interested and actually want to enter this field. So one of the reasons the area grew so much was we collect gazillions amounts of data. I don't even know what to call it anymore, what the power of 10 is. But what's throwing off a lot of this data is both the internet, and the IoT stands for Internet of Things. So they're devices, around the world that it's collecting from phones, from your refrigerator, from your Nest home device, you name it, it's collecting data, and it just grows exponentially. But what really enabled us to start using this data for decision making and recommendations and improvement in human life is the computing power finally came about. One of the stories I tell is one of my early projects, I did an effort for Kraft cheese. And I had a model I wrote for them to figure out how much cheese to buy or make at their factories. And, the model I ran took 8 hours for one version of it. And they had just used a brand new computer that HP came out with. And now the same size model, when I went to Qualcomm, I wrote a very similar model to it. It took literally seconds on my laptop. So from like 1990, when I ran the Kraft model, we got 8 hours. The same model ran in seconds on my laptop in like 2005. So, and then even now we're like even way beyond that. So this explosion in computing power has really enabled this kind of work. So now, in AI models, we can look at millions of variables, and this is not uncommon for, if you can imagine, different columns that have information, millions of columns, and they run these programs on, not just one computer, but many, many computers, processors. That's the whole concept of now having the cloud, where you can fire off an analysis and use thousands of computers at once, and it'll crunch on a little piece of your problem, and then come back, unify the answer. So here's kind of like the timeline that I put together. I thought these were kind of interesting and kind of showed over the last more than half century of where things are going. So like in 1943, there are people thinking about, can we mimic the brain? So can we do some kind of modeling that looks at how neurons are collected and the strength of the connections as part of maybe building a model. But then it was just more of a research effort or thought process. Then I don't know if you all remember the movie Imitation Game, I believe, with Cumberbatch, who played Alan Turing. So Alan Turing was a famous mathematician, and he put out a proposal out there that people still talk about today that says, do you have a computer now that you can't tell when it's responding, whether it's a human or a machine? It will pass the Turing test. So sometimes, like about now, people are claiming, or even sooner, people are claiming that they passed the Turing test. But this is one of the judgments, or one of the, the bars that are set to figure out, do we have true artificial intelligence? Can you tell if it's a human or a computer thinking? And then the phrase itself was coined in 1956. And people are always working on this theoretically or had, ideas about it. The first, I left the word out, in 1966, the first chatbot was built. And so I'm sure many of you have dealt with chatbots off and on. You know, it's a little pop-up window. Can, you know, if you're looking at the, you know, I was looking at the, how's it, Home Depot, if I want to go buy something online, little pop-up window comes and can I help you? That's a chatbot. So in fact, the first chatbot was put out there in 1966, or one of the first chatbots. And it was called Eliza. And so, you know, but then it was really like following more set instructions and rules and directions from a script. I've got someone speaking up. They want to mute. Thank you. So now, so if you think that it's very novel to have these chatbots now, the idea was, you know, initiated early in the 60s. And then I was very surprised to find this in my research. The first Android robot was built by a Japanese firm in 1972. I mean, it didn't have the sophistication that the robots now have, but in fact, it was Android, full-scale Android, and it could walk, you know, with legs and grip with its arms and see things using 2 cameras. So there we go. It really dates back into the 70s. And then the hype, then you get into like the mid 70s and 80s. There was a lot of hype, you know, about what AI could do and promised, but there was, you know, the investors didn't see that coming, didn't deliver. So it was overpromised. I have a note here: overpromised by delivers, and unnaturally high expectations from end users, and extensive promotion in the media. I'm quoting a source I read, but it didn't happen. So we kind of went into what they call the first AI winter. You didn't see as much being cranked out, either practically, but the academic work kept happening at the universities. You know, there were some key players in this field that kept, you know, working on the area. But again, the commercial applications were not as strong. And then in the 1980s, now this is where I started working. I remember expert systems. You know, they called it AI. I remember that's probably the first time I started hearing about AI. But they were rule-based. So you would have a computer programmer hard coding a rule. You know, if you see this, then do that. You know, if this condition is there, then make this recommendation. Or if this group of situations are there, or the numbers are in this range, then here's the recommendation you make. So it's very hard coded. It was not that the computer was learning. It was an expert, we call it domain expert, you know, telling the programmer, if you encounter these situations, here's how you need to respond. And they called it AI, which again is kind of it's contradictory to the current definition. And then again, apparently, you know, when I read about, you know, in the text, we kind of went back into another AI winter. So it wasn't ready for prime time, I guess. Then finally, again, people were addressing it. I guess many of us know about Roomba vacuum cleaners. They actually came out in 2002. I was surprised that it was that early. And, you know, at the time, you know, in 2002, it was really basic. So the machine knew if it bumped into the wall, it needed, you know, to turn around and go a different direction and to keep cleaning. So it was very basic. But now, you know, it detects, the new version, you know, sensors can detect presence of obstacles and dirty spots and, you know, keep itself from falling down the stairs. But the initial one actually came out in 2002. And then when I was looking at the Google Trends, I was trying to figure out why there was a hype, maybe. And the first rover, Mars rover, landed in 2004. So now we actually have, you know, actual robotics, real robotics doing things. And so this was a true accomplishment with the first Mars rover. With plural rovers, I think it should be singular. And then I've got more detail coming, but you know, the next major notable thing that many people knew about the press with AI, I don't know if any of you might have watched it, was in 2011 where the IBM Watson computer played Jeopardy. I don't know if you all cared about, you know, or watched that program. And it won, I guess, most of the games, you know, against the champions. And I've got a slide on that talks about it a little bit further. And then the subsequent year, this is a big deal in our field, that now they're writing programs and mathematical models that can start to recognize images. And the first one were cats. People just love uploading cats on the internet, so they wrote code to start recognizing cats. You know, then obviously I've got more in between I'll talk about in the subsequent slides. you know, another major thing, for example, like in 2018 now, is now we've got self-driving cars on roads. So it really dates back, you know, as I say, you know, many decades. And you can see people thinking about this very early in the game, trying to mimic the brain. And again, the mathematicians and the programmers and the cognitive people were really at it for a long, long time and didn't give up. So yeah, let me talk about the Watson. So they taught Watson to understand text and well enough in context to be able to answer questions and defeat these Jeopardy champions. And the thing too is Watson, you know, not only had this natural language processing ability built into it, and also then it was still, and I'll talk more about natural language processing. It's really evolved greatly, but good enough to pass it. But it also had its own data stores as it was learning that it could tap into, and then its algorithms. But this was really a very, you know, commercialized success story, and also a big marketing story, because since then, you know, IBM has been pushing the Watson capability for all kinds of uses, especially in the medical area. Because now Watson can go through it and read, you know, in pharmaceutical, and read documents and start to make sense out of them and utilize that information.
Maria, did you hear that news? I don't mean to interrupt your presentation.
No, please do. Go ahead.
Did you hear that news that IBM Watson, their health-focused division has been sold off?
No, I haven't. I'm not surprised though. In a good way or a bad way?
It sounded bad, like it wasn't.
Was it delivering?
Profitable or something, yeah.
You know, I'll have to read about it, you know.
Okay.
This work is not perfect, but again, it helps, you know. And maybe a large organization is not the place for it to be, too. I mean, a lot of this stuff has been with startups. Truly, right. You know, really, that startups have done sometimes even more than the major firms. So this is it. So this is interesting. So I remember this happening in the 2012, 2013. You know, we have all these images out there, and people now are trying to figure out, can we identify what the picture is of, what's in the picture, you know, and it could be an object that is upside down or a glimmer of it type thing, but understanding what it is. And so I mentioned here this gentleman, Pierre, I can't pronounce this, Samay. He won this competition. Kaggle's a big competition website. And for years they've been putting out data sets, and people will compete to try to come up with a model to solve it. A lot of these requests are practical requests by companies, and sometimes they'll actually reward the winner, you know, with financial amounts. But the big thing was then, you know, they were keep trying. It's simply, can you tell if a picture is a cat or a dog? So again, it could be multiple cats or upside down cats, and the whatnot. And so, you know, like these data sets, like Kaggle will maybe give you 10,000 pictures to figure out. So in this case, this gentleman, he had to teach the models, and the techniques that he was using in our field are called computer vision and deep learning. And deep learning are super complicated mathematical models that, again, can have millions of variables, possibly, that have to be estimated. But he used here those two algorithms on 25,000 images. So the set that he was given for the competition, I didn't collect here how many he had to classify, but he achieved almost a 99% accuracy. And I have to say, the animals I picked, by the way, to show you, one is my son's dog in Denver, and the cat was mine. So I wanted to share my pets, the family pets. Now for Alexa, so Alexa was released by Amazon. This is the virtual assistant that Shauna was talking about, that our competition's about, you know, in 2014. So again, the field's evolving. So we're going to trying to show, like with IBM Watson, it can think and make some decisions, you know, and answer questions. And then we move, you know, we're moving both in time to trying to look at pictures and make sense out of them and identify them, you know, earlier in the decade, and also with sound and voice. So you've got Alexa now understanding the spoken word and able to respond in many, many different ways. So this was the first release of, you know, the Alexa, and then Google was about the same time too with their, you know, Hey Google product. But you can watch this evolution, and it's not that long ago.
because if you go back to the prior decade, you don't have this even there. So we had the mathematics, but more so we had the computing power to do this. And then again, more continued work always on trying to make sense. So here's another example where Google, they took, take this, 260 million images, okay? And this is what the artificial intelligence models were learning on. As a child, as a baby, it's gonna know over just pretty quickly what a child, what a man is or a woman is, or its mom or its dad or its relative. Well, they started teaching, their AI models to identify people, like 260 data sets, and they fed it 13,000 faces that were well known. The data set was called Labeled Faces of the Wild, but these were like well-known people. And the Google system was able to identify over 99% of these people. So this is now we're starting to get spooky, and that's why I put down, I know you. Alexa, think about when you use Facebook, for many of you do, or other products, it'll say, oh, you were mentioned or you were identified. That's this technology. So it's pretty recent, relatively speaking, in terms of science and in math and computer systems that they're now able to do this. Another big thing that was really talked up, I was at Qualcomm at the time, and the super nerds that I knew there were like, oh my God, it beat the champion at Go. And I'm like, what is Go? Well, Go apparently is an incredibly complex game, far more complex than chess or checkers. And I mean, it takes, like, there's a world famous champion. I mean, this is like one of the supreme games to beat, and it was able to beat him in multiple games. So, and also this, in this competition, they were using, again, a newer type of algorithm called reinforcement learning. And I'll talk a little bit about that too in a couple of coming slides. So not only do you see in the last decade the capability to do, question and answer, voice, picture, but really sophisticated game playing and decision making coming with this field, to the point now where, in 2018, Waymo's part of Google, it was on the public roads, and it drove 10,000 miles. So, unless you looked, I think I don't know where they were driving. They might have been driving in Phoenix. I forget where they were. But you would have an autonomous car. So we're not there where you and I can go buy one and have it drive us around. By the way, I can't wait for that. But, it's evolving constantly year by year. But again, it's still fairly new. That 10 years prior to this, they were doing this maybe off track, or 20 years ago didn't exist. And this is another tremendous accomplishment in 2019. Again, it's all about this learning. And there's a concept in AI called transfer learning, where you train the models or you train the computer on a given data set, but it extends that knowledge to another area, or you build upon it. Well, they trained this, using this open AI organization, the robot with simulated data. But when they gave it the Rubik's Cube, which it never learned how to do, it figured it out based on the prior knowledge for other maybe similar circumstances. I'm not quite certain, but was able to solve it. And then again, with its hand. So not only is it solving it intellectually, but it's solving it physically. And this was just a couple of years ago. And then here we go. So think about all the stuff I've talked about. I talked about, understanding patterns in data, how to classify, how to predict images and sound. Now all this is coming together to help us to tackle COVID. So there's tons of these, because thankfully the data is all public, so really encouraged a lot of people interested in data science or just in COVID, or helping out how to tackle in different problems from different perspectives, like in researchers, determining who's at risk of going on to severe respiratory disease, or you've got, which is really straightforward, like predictive analytics type stuff. Then you've got, like a classification problem. A person has a cough, so it's got to listen to it. This is a sound, and then figuring out, is that cough COVID or not? Is it asymptomatic or not? Another example is like CT scans, which is image again. So it's leveraging all this learning and analysis based on deep learning and what we call image recognition for CT scans to isolate people, who might have COVID. Another one I like quite a bit. This backstory with this is the bottom. I said the graph is by Yu Yang Gu. I only follow Twitter for a couple of people, and one of them's a different statistician, and he started pointing to Yu Yang Gu, and he's a young man. I think he's maybe 25, somewhere between 25 and 30. Relatively new in the field. On his own, he built. You should look up his site. It's COVID-19 projections. He's got data that is so well represented on the situation on COVID to the point where he did it humbly, I felt. He was on Twitter asking, did the CDC mispost some data? And they did, by the way. So it's correct. I think it was the CDC. But I was wondering early in the game, could anybody, or could I build a model like this? But fortunately he did, because it is quite complex with all the underlying assumptions that he's got. If you read the website, you'll see how thorough it is. But he's looked at, and he's projecting based on infections and vaccinations, when we might approach herd immunity. That he retitled the Path to Normality, which I thought was nice, a little more upbeat, I thought. But he updates us all the time. So I found this comforting, frankly. In fact, I wrote to him. I sent him an email, congratulating him on his good work. And I said, thank you for the comfort. I go, there's some hope here. We can see something improving and getting better. But it's interesting how he's projected this out. It's based on AI and machine learning technique, various machine learning techniques that he does this work and habits. So this is the spooky one. I found out about this 2 days ago. And, I'm active on LinkedIn, so I occasionally see people posting on LinkedIn little videos on, robots hopping around, and I've even commented they're spooky. Well, apparently just the last week or so, the New York Police Department sent in their DigiDog. This is a robot dog, that can see, and they sent it in on a home invasion to explore what was going on. And apparently it came in the news because Alicia OIC, how do you say her name? Alicia, I can't say, what I'm talking about, the representative from New York, was criticizing the police department spending money on this instead of spending money on schools. But I find it really creepy. Can you imagine being in a situation where you're in your house and something's going on and this robot dog comes walking in? Hopefully it never happens to us. But it's there. And they're using it. That's the thing. They're using it in real life. So a little more background. I didn't talk to the students with Shauna's class, but I thought you guys might find this interesting. This is a big grown into a very complicated field. So it's not like people go, oh, I'm a data scientist or I do AI. It's a broad field now, and now it has its sub areas. And it takes a lot of work to stay on top of it, and sometimes people will focus in on sub areas. So there's different things that machine learning does, or AI depends on machine learning. So you're classifying. So you've seen this with fraud. Maybe you've gotten a phone call that that from your credit card company, we think there's a suspicious transaction. This is from techniques that are used in classification. Or you're scoring. What's your FICO score? They have within it an area called regression type models that do that, and it's called super because the learning, you have kind of three types of how can I put this? Algorithms for three types of data. So, for example, in fraud detection, let's say someone's building the model for the first time. They have known examples, so they'll feed it thousands or millions of transactions, but they're labeled, so they know when they see these certain patterns in this one example, it's labeled as fraud, and then other examples are labeled as not fraud. So the models learn that. So it's called supervised learning because you're directing it to understand something or known already. And so supervised learning, a lot of classification and regression does it. Unsupervised learning is you don't know what the final answer is. And an example of this, probably your best one is the more lower one, the clustering, like in target marketing. You're looking at groups of people that are similar to each other so you could recommend something to them. Like Amazon would do this, or stores will do this. They see you buying petite women clothing. So they see, your pattern of buying women clothing, maybe how much you spend. I don't know, other brands, as opposed to someone else who's buying socks. Okay, you're going to be in the, petite woman's cluster, and so you're going to be maybe offered up an ad that targets you maybe to a new line of clothing. Whereas with socks, you might say, oh, you want some shoes? So, but these are groupings. They don't know what these customers always bought. They just see these patterns of habits. So they group them together, and that's called, the data is called, or the learning is unsupervised learning. And the same thing with text in natural language and spoken language. It falls into techniques like that. It looks at the pattern of the words. And like, actually a better example of that is like when the newspapers will classify articles. It learns to understand groups of article. Is it a finance article? And then in the sub areas. This falls in the area of unsupervised learning. So there's genomics. And then this newer area, this reinforcement learning, its applications are like self-driving cars and gaming and robotics. It is like a very interesting approach. It looks at, it's trial and error. And what it's like, it's algorithms that do trial and error. And so they're trying to like get as many points as possible or as many things right as possible. And that directs them in learning. So it's almost like, it's like human being. How do you learn? You make mistakes and then you correct. And in the long run, let's say you become more wealthy or you get a better grade. You're practicing more. And it's its own area, actually, of machine learning. So whenever you talk to people, this is a classic interview question, by the way, for new people in the field. Tell me the difference between these three. And it's important because then it tells you what kind of data you're going to be using and then what kind of algorithms you have to bring in to use them. And then for Alexa, for example, where does that fit in? So you see the person on the left speaking, it's picked up by the sensors in the Echo or the Alexa. And now it's using, again, as I just spoke about, algorithms that do what's called speech recognition. So it's in that family, or text to speech, and it's using very specific types of mathematics, to understand, to take what's going on. And then if data has to be fetched, it will take it from a database. Like our team is asking, like, what is the ozone, today in San Diego, because the person wants to go running. The Alexa AI will take those words in the sequence of the words and start to understand. It's looking for something, with ozone and maybe well-being. So it's not hard-coded, like if you see ozone, then do this. It actually understands the context and what you're trying to ask it. I mean, it's that sophisticated. And then it leverages the database to, find the right numbers of response. And then in turn, reassembles it into speech and gives you back an answer or types you back something on a screen. So this is where, within Alexa, how AI is being used. And then just to give you the eye chart, so I think one of my last slides, this is a very sophisticated field that takes a lot of time to learn. I have an advantage because I've been in the field for so long. I kind of watched its evolution, and I had time to learn stuff. So I heard, I need to learn more about, the top recurrent networks. I could spend time on it, but I understand the underpinnings from my own education over the years. Whereas someone new to the field, they have to start picking this up. And I'm reading now that people are more focused on certain areas. So now you'll have someone that is more focused on language or image, or maybe people that are doing more what they call classical learning, where, they're working like for FICO, which is right down the street here in San Diego, to compute your scores or risk evaluations much better. Maybe they'll use more classic techniques that tend to be the more bottom half of this, whereas the top half is really much more recent, like in the last 15 years. And the bottom part of this, some of it's newer, but as a whole, it's been around for a few decades. So I would get a chuckle out of it when I was interviewing new people to come work for me at a school. I go, tell me which ones of these you know. And they would talk about linear regression, and they're like, oh, this is fancy AI. And I'm thinking, no, it's been around since, I don't even want to remember. I'm going to say the 40s or something. It's, it's super old, but it still is used. So the field is challenging because you have to constantly learn, and new stuff comes out all the time. So if someone's going to, work on a language problem, even a couple of years ago, there are new databases or methods you have to learn. Otherwise, you're not up to speed. So it's a fascinating field and quite challenging at the same time. So where does it go? I kept thinking for my last slide, what do I say? Where do we go with AI? I don't have an answer for you, but I keep talking about I want a robot to give me a massage. Well, I guess apparently there is a robot. These are apparently 2 robots that are doing massages. So I guess this is for real. So I guess I finally found my happy place. I need to find out where they're doing this. Where does it go from here? I don't know. I mean, I was trying to do some research, but even if I put anything down to tell you, it could change tomorrow. But it is a constantly evolving field. Tons of startups are in this area. It's almost like if you want to start a company that's computer-based or data-based, and you go for funding to a venture capitalist, they're going to ask you, well, what's the AI within your product? Unless you have that, they may not be as willing to give you funding. So that's really about it. So there's a picture of me from a San Diego event. So if you have any questions, I'll be happy to take them, or comments. I'd be glad to hear them. You want to unmute? I'm ready to go.
I have a question. This is Jane.
Yes.
One thing I find creepy, and maybe you know how this happens, if my husband looks up something on his computer, which is upstairs, and I'm on my computer downstairs looking at Facebook, like if he looks up running shoes,
Yeah.
for example, on my Facebook page, running shoe ads start to pop up. How does that
I
happen?
think part of that is the cookies that they capture. That's the old school answer. I don't know if they're still using just cookies, but they're tracking your data. This is part of that target marketing I talked about. They're picking up all this data and running it through models and saying, this person looked at this, so we're going to suggest that. And now there's this discussion of you should own your data. The Europeans are coming down on this, and the US is not talking about this. Like, how much data on me are you allowed to have and use? So they're capturing this data of what you're doing, what websites you're visiting, what you're asking. And unless you say you can't do that or no way to stop it, they got data on you. This is now a societal problem. That there's too much information out there.
Isn't that why
1984 has arrived?
Sorry?
1984, do you remember the
Oh, yeah.
novel?
Oh,
Has
absolutely.
arrived.
Yeah. Yeah, there's too much out there. And then there's this debate on how much they can have. Like, you notice now we get these pop-ups that say, do you accept cookies?
Mhm.
Yes.
That's how they're capturing. If you say yes, they go, oh, great. I'm going to capture what you're doing.
Right.
So
So I raised my hand.
Oh,
This is Sherry speaking, Sherry Ludwig. I had a question for you about, there are companies now, I think I was on Navient and for my daughter's student loan, and there's another company, I don't remember what it was, an insurance company, and they say, and this voice comes on and says, it's something with an R, pardon, it's not Randa, it's Rondo or some such name. And I'm a new helper for, I'm a AI helper for the company, and I can get you all the information. It's just eerie to give information to a robot and wonder, where is this information going?
oh yeah.
Have you dealt with that before?
Well, I came to San Diego actually to be a VP of a web analytics company. That's what got me to move. And we were collecting cookies and all this good stuff at the time.
Mm-hmm.
So, I mean, if you voluntarily give them that they got it and they can potentially resell it, they use it, there are firms that's their goal, is to collect this information and package it up. And that's even going back a few years. I don't even know where it's at right now. But whatever they can find about you is valuable. That is truly the scary part. That's why I'm
That's
really,
really scary.
like, yeah, I mean, letting them know, like, for example, I mean, the whole business of healthcare information or financial, you just have to be careful. I don't even know how to give you generic advice. All I know is they're eager to collect as much as they can on you because they want to sell you something.
Yeah,
Or
exactly.
or persuade you to do something, like during the elections.
Right. Thanks, Maria.
I have a question. This is Ellen Souter.
Uh,
I don't use Alexa, but it's a machine you talk to and it talks back. Can it pick up background information when you're talking to other people and use it? Can it invade your privacy?
It could, and I don't know if it does or not. That's been a concern about from people. Shauna, I don't know, do you have any thoughts on this one?
Alexa does.
Okay.
Can you turn it off then?
Yeah, unplug it. I unplug mine.
Oh, you unplug it. Okay.
Yeah, in fact, what's funny is when I do the mentoring session, I have Alexa sitting right behind me, and when I start talking about her, she pipes in.
Yeah, we've had that happen at a dinner one night at our house. We have Alexa, and she surprised us. All of a sudden, it was like we had another member at the dinner table.
Yeah.
Yeah,
And
Maria,
Google's got one too. Sorry?
would you stop sharing your screen so that we can
Sure.
see everybody now?
Yeah, thank you. Yeah, let's do that. Let me do that.
Be easier for people to ask questions, I
Oh,
think.
yeah, absolutely. Yeah, okay.
So I know that I just want to pipe in and say with Alexa, there is a way that you can turn off or turn on some kind of privacy function. I don't know it. I couldn't give you instructions, but I know there is a way to do that
Mhm.
so that nothing is captured or nothing is stored. But I've read articles that talk about how your data, your voice data is recorded, stored in a database and can be listened to by maybe not anyone who works at the company, but people in a certain department that are reviewing. You would know the term for it, Maria, not me, but with the reviewing the data, maybe to look for patterns or to understand a
Yeah, I don't know.
dialect.
I mean, they could use it maybe to train models.
Yeah.
But I don't know if they have to ask you permission or not. That's an ethical question that probably needs to be asked at some point. Like if they pick up, your private conversations, can they use it to train their models?
Mhm.
I have a
Because
question.
it's data. That's what that's what we want. We want data to teach models to do something.
Yeah.
So I can't say definitively if that's what they do with it, but it could be. Again, that's a cool question to ask the folks over at Alexa. What are you doing with this? No, what are you doing with this background information? Yeah.
I don't think they have bad intentions. I think, like you're saying, they're using it to train models and look for.
It's a freebie. If you think about it, it's a freebie to them.
Mhm.
If you're cruising online and you're not suppressing sharing information, it's freebies for them and they love it.
Yep.
Yeah, I got all kinds of stuff. I would get suggestions from Google forever on stuff I don't want anymore because they remember it.
And same thing with Google Maps. I don't know if you know that, but you can turn that history tracking off too. So people like Google, if you want to, I don't know if it's people, but so no one at Google can see what you're up to. If they really wanted to, they probably could, right? Like
Qualcomm wanted, I'm trying to remember now. You probably would have to ask permission. I know there are I wasn't on this team, it was other machine learning teams. When they were building their products, AI products, about 5 years ago. Yeah, they were wanting to track people on their phones to see when they were going to work, how long it took, so they could give them phone apps to propose stuff like, there's a sale at the store that you might like, and you go near it, type thing. It is creepy. It's really creepy.
I don't know if I'm muted or not. Am I muted?
No, go ahead. Go ahead, Barbara.
One thing that has concerned me greatly is all the QAnon stuff. And I want to know how much artificial intelligence that Maria might know has been involved in all the messing around with the elections, all the secret messaging that is sort of creeping, like if you access, let's say you're a right winger and you access things that are right wing, it is felt that QAnon, which could even be a foreign country at work, is using artificial intelligence to start tweaking into your opinions. And before you even know it, because you've been led from place to place, from a very innocent place to a place that's not so innocent, is this part of what's going on with artificial intelligence?
I mean, it's feasible. I really can't answer your question, but things are feasible. You know, if it understands the patterns, you know, and what you look at, if it has access to this data and it can, I say the question is, I don't know the mechanics of how it would carry the whole thing out.
Well, that's a highly suspicious area, I think.
Yeah, you know, I mean, I think a lot of people first became aware of the power of AI when, what was it, the Analytica company in Britain was persuading people, Cambridge Analytics was persuading people during the 2016 election. I think people started to understand the powers of what AI and machine learning could do. But that's not my field. My field of expertise, or, I mean, I try to stay away from all that stuff, frankly. You know, I don't even want to even start looking around, because next thing I know, I might have a cookie or something from these people. You know, I'm serious. You know, I don't want to get exposed.
I have a question, and it may not have, this is Ellen. It may not have to do with artificial intelligence, but it's sharing of information. I'm asked on my chart if I want to share my information shared with other medical centers.
Okay.
Did that get carried away, or is that pretty much?
Well, they have HIPAA. You know, HIPAA's pretty tight. You know,
I always say yes, because if you're going to be in an emergency and you go to another hospital and you've said, we work at the hospital, so, and if you say no, getting your information from your regular hospital becomes impossible. And that might be useful information. And I will tell you that even if you are, I will give you an example. My daughter is a research nurse at Amazon. If you have a family member that's been admitted somewhere and you decide, because you have access to that particular hospital, and this happened, one of the nurse's son was in the hospital and she accessed his chart, she was fired instantly.
Yeah.
So they are pretty tight with that. So I sign all the time that you can have all the medical records on me that you want. Actually, everybody in the world probably could, because they wouldn't be interested. But in the meantime, yeah, if you say no, you may be jeopardizing your own life.
That's interesting to know. I didn't know that part of it. Yeah. I just figured they were asking like for research purposes.
No, if they ask, well, they may, sometimes it's research. I'm in 3 different studies. So, you know, I've said you can have, like I got my vaccines early because I joined the AstraZeneca study and for vaccines for COVID. And they asked, can we use your DNA so that they can keep watching for stuff? And I said, yes. But you also had the right to say no, and then they could not do anything with that.
Pat
so
Green
there's
has
certain
her
things.
hand up.
Yeah.
How do you compare Alexa to Siri, besides the fact that Siri is on the phone?
I mean, they're similar. I believe they're similar technologies. I mean, I don't have an iPhone, so I don't use it. But, you know, I think at the end of the day is if you experience with both and one answers questions well and one doesn't, but I'm sure the underpinnings of all of them are similar, you know, in the mathematical aspect of it. You know, I have a Google in my kitchen and I've got the Alexa upstairs by my desk. Google doesn't play music well for me. It keeps interrupting with commercials. At least Alexa doesn't do that. So I mean, that's
That's
just one
true.
implication. But yeah, it depends how far along they programmed it and the skills. But underlying, all I care about to me is natural language processing. Those techniques, and then again, the other thing is it listening in or not. I assume Siri won't listen in. I would hope.
She might.
She might, yeah.
Yeah.
Well, I
Well,
found
then
out
you can't give you a assessment.
you have to say, hey, Siri. You can't just say Siri. You have to say, hey, Siri.
Pick it up if you say it. Yeah.
And we learned in our class that Shauna's put on, it's called the invocation.
Yeah. I wanted to say something. I'm listening to all you ladies, and a lot of the comments are oh, my AI is creepy, or it's taking my information, and I suppose it is. I don't, I really don't know if it is or it isn't, but from the articles you read out there, some of your data is recorded, like Maria said, and used to analyze or train models. But with our program, I just kind of want to give it a plug. We're focusing on AI for good. So we're asking students to address the UN global goals, and how can AI be used to do that? How can AI be used to improve the world, or build a better future with voice, or build back better from the COVID crisis? So there are many things that can be done.
No, yeah, thank you for saying that. Yeah, I don't mean to badmouth it. I mean, it is, yeah, the insights we get everywhere, and the productivity as humans is immense. I mean, just think about it. If you have, and this is a number of years ago, AI looks at your breast scans, and it'll pick up cancer faster or better than a radiologist, or it'll complement, or it'll help the radiologist. Something that basic is immense. And this is image processing. This is classic image processing that was figured out a number of years ago. But, so there's tremendous use. It's just now we're at the point where we just have to be careful that we're at this point in society to protect our privacy so it's not misused.
Yeah, one of the reasons they were able to get vaccines out so fast for COVID is that there was data out there from the previous SARS, because it's a SARS disease. And so people at both, of course, China, but the US also already had the underpinnings, and they were able to use AI to start. They didn't need human blood or anything. All they needed was the models from the first SARS to start working on the vaccine that was needed for us to get the vaccine out so fast.
That's a great example, yeah.
So it's a very positive example of where AI really helped us get the vaccines out as fast as they wouldn't have been able to without it.
There's another aspect of AI that's also being discussed, though, is in competition among countries. Like to have dominance in technology. This is now one of the areas that countries are looking at to be dominant in. And there is a concern in the US, will China outstrip us potentially in the field of AI? So it's a whole another ball game of sorts, of which, long running for productivity, countries being on top of it and being productive and putting out products and using it and not letting another country beat it out. There's a book that was written by Kai-Fu, what was his last name? Kai-Fu Chen, about AI superpowers. I read it a couple of years ago and it made the press, where he's talking about how the US has to watch it, that China is out there competing and they're quite powerful. And see, they're not hung up on privacy. So they've got tons of data. And their populace is comfortable using cell phones and, ordering and paying for everything. So they're capable of, have data and computing power. You can get a lot. That's, they call data the new oil now, by the way.
I like to go back to a very, very old example. I use it in my class, and that is the discovery of electrolysis of aluminum from bauxite. The person that started the age of aluminum was Charles Hall out of Oberlin College. And he is the one that figured out how to separate aluminum by electrolysis. And almost concurrently, so did a guy with the last name Heroult in Paris. What happens to me is that once you reach a certain point of learning in whatever it is, all of a sudden, everybody is soon going to have that baseline knowledge, which allows them to move forward. And once you've done that, everybody can do it. It's just a matter of who decides to do it. And I don't think at this point it's even worth fighting about the idea of whether China or the US will move forward with the AI. It's already happening, and it's the cat's out of the bag. So we can maybe fret over it in our own minds, but it's a done deed.
Yeah.
Lynn, did you have a question?
Lynn's got her hand up.
Okay.
I do have a question, and that is all about the Russians spying on our networks. You know, I mean, it's based on that thing that happened in Texas last week. I mean, you can easily see them knocking down our electrical grid in a heartbeat. And what would happen? How do we defend against that?
Well, didn't they build the NSA to help with that a number of years ago? And then we know we have experts in cybersecurity.
You know, the Russians are in there. We're not. You know, we're discovering their inroads way after the fact.
I hear you. I mean, I don't think we know a fraction of the story of what's going on between the countries. You know, all I know is we have to have well-trained people in the right place and the right desire to protect ourselves and not drop the ball. I mean, that's my personal take on it. Yeah, I don't know. I just said we probably don't know the half, not even a fraction of it, of what's going on.
We don't, because a certain person didn't care.
Well, ladies, I was going to recommend that you read Snowden's autobiography.
Interesting.
It's really an eye-opener.
Yeah. Well, we're about at the end of our time here. I'm just looking at the names here. I was wondering who Joseph is. Is that one of your students too, Shauna?
It may be. I need to see the last name.
O-J-O.
Oh yeah, that's one of our students.
That's what I thought. Okay, well, welcome, Joseph. Can't see you, but welcome. And thank you, everybody, for coming. Thank you, Maria. That was so interesting.
Yes.
I feel like I learned a tiny bit. There's so much out there to learn still, and you really helped us, I think.
Just to give you a taste of some of it, yeah.
Fabulous presentation. Thank you very, very
You're
much.
welcome.
I think I'm a little smarter than I was an hour and a half ago.
Yeah.
I